Hello, so far we have learned how to, in general, how to find the expressions for the distribution of one function of two random variables. And we had a couple of examples. Now we want to have a more difficult example, which is if you have two random variables, x and y, and then I want to divide, these are the input, and the output z is equal to x divided by y, or y divided by x. And I want to find the distribution of the division. So similarly, we need to use the draw a diagram. We plot these functions and so on for specific values. And so we consider this function of z equal to x divided by y, and we specify value of z for weeks, let's say for z equal 1 or 2, and then we plot. If z is equal 1, we get x divided by y, and then from here I get x is equal y, and then I plot it. I will get this line. So this is z equal 1, which is equal to x divided by y. Now, if z is equal to minus 1, then you get x divided by y, and then you get x is equal to minus y, and then you get this one. So z equal minus 1 will become x divided by y. So you could plot these for different values of z. If z is equal to 0, then you get another curve and so on. For a given z, this curve will become a line, and we consider another dz, so it becomes another line. So we get two lines. So we have to plot this one. So let's say z equal xy. So let's say z is positive, you get one line. Okay, so y will become yz become equal to x, and if I put dz, you get another line. So depending if dz is positive or negative, and then we plot these two lines. Okay, so one of the line is this, has this equation, the other line has this equation. Then we have to identify these two regions, and then we could subtract them and then integral over them. So I plotted these two lines when dz is bigger. So and then delta dz becomes this blue area, and the yellow area is this. So this is dz union with this one. So you have, it is divided in two parts, and the yellow one also is divided in two parts. So if I want to have f z of z times dz, I have to do integral over blue area. Of f x y of x and y dx dy, and assume that dz is small enough, and then simplify. If I want to have the CDF f z of z, then I do the double integral of the same thing over the yellow area. Okay. So let's do the boundary of the integral. So the area corresponding to this one is yellow, and the area corresponding to x divided by z bigger than z and smaller than z plus dz is the blue area. So this is the union of this blue area and this one, and this is the yellow area. So therefore, for the yellow area, I have to put the boundary of this integral such that to cover yellow area. But the yellow area has two parts, so I need to write two integrals. The first integral covers one of these two and the second one covers. So you see that the distinction between the upper one is that y is positive. So y starts from 0 to plus infinity, and in the this one y varies from minus infinity to 0. Now, for a specific value of y here, if I'm in the yellow one, for a specific value of y, x varies from minus infinity up to this line. And the equation of this line is x is equal to yz. So x varies from minus infinity to yz. Okay? For the lower integral, so for a specific value of y, so y is on this line, so you are dancing on this line, and x varies from this line to infinity. So x varies from this line yellow, this line that x is equal to yx, okay, to plus infinity. So you simplify this integral or calculate this integral. This gives you the distribution of the cumulative distribution of z. Alternatively, you could write fz of z as a double integral over the blue area. But the blue area has two terms. One component is the lower part, and the other one is the other one. So you have two terms. If you are in the upper one, y is positive. So y starts from, let's say, 0 to plus infinity, and in the lower one y varies from minus infinity to 0. If you are in the upper one here, for a specific value of y, your x should vary between this point and this point. So your x varies from y z and from to y z plus dz. But here, for this value of y, your x varies from this point to this one. So you see that it's the same 2 points, but this one is smaller than this one. So I put it x varies from y times z plus dz up to yz. Okay, if you don't put this one in the right order, you could alternatively put a minus, and the same functions. So now you could say, oh, if this dz is very small, close to 0, then what will happen? So alternatively, the two terms, you could simplify it, approximate it, and obtain this one. So this is a general rule to find the PDF of the division. Obviously, you see that this dz simplifies and eliminates it from here. So the PDF for the division of any two arbitrary distribution is one single integral of x varies from minus infinity to plus infinity of fxy of x and xz, and then absolute value of x dx. So this is the integral you may use. Obviously, you could change the dummy variables from x to y.